Yeah. So basically, in today's class, we'll start with a discussion of VHDL. In this particular, mainly, we're going to discuss how to implement a VHDL code for basic gates. With the help of this, how to implement some basic program that is available in your question paper will discuss. Okay. So the need of VHDL you know very well. So mainly, if your circuits consisting of lot of integrated circuits or lot of switches, in this type of scenario we have to use some programming language called hardware description language. With the help of this language we can able to describe the whole hardware. This language is in case sensitive. Here we can use capital letters as well as small letters. Both the letters we can use in the case of VHDL. Coming to what is the template for VHDL to write a program, to describe any. The firstly we have to discuss, we have to define what libraries we require. That is first point. After defining library, we have to declare what entity, for what entity we planning to write the program. After entity declaration, what is the architecture declaration for your program. These are the three important blocks to write a VHDL coding. Entity mainly deals with port elements. Suppose take example of a comparator circuit. It consisting of this comparison of two variables A and B and one output where A is equal to B, another output A greater than B, another output L, that is A less than B. So in this particular 1-bit comparator circuit, there are 2 inputs and 3 outputs. So like this, here we have defined a standard structure to define the port list in entity block. In the case of architecture block, what type of syntax or what type of logic we are going to implement, that particular part we have to write down in the case of architecture. To define this whole thing, let's take the example of simple AND gate. Question will be write VHDL code for logic AND. To write a program for this, first, as just now I explained you, we start by describing library IEEE, terminate this one. The usage of colon here, semicolon here is, once you write the semicolon means this line executed. If you forget to write this semicolon, without writing semicolon, if you start another line, it will be take continuation of this. So once you write a semicolon, it will terminate automatically. I'll write comment here, comment. The usage of semicolon is termination of instruction, termination of instruction or line, whatever. So after library declaration, describe the standard. This use IEEE dot std standard logic underscore 1164, this is a version dot all. These are all common lines, follow for all the programs, just to practice as it is. After library declaration, now start entity declaration. So entity, start with entity and name of the entity. The name of the entity is basically, you can give any name to your program. Suppose this is the AND, just I am giving a name of my entity is some AND underscore gate. Just I am giving this name. This name is called identifier. This is only for identification purpose. You can write on and underscore south also, and underscore my first program, something you can write on. But these are not matched with the inbuilt function available in the system or a Verilog or a VHDL program. So unique name you have to give entity and underscore program is. So I have already told you, entities mainly deals with port information. What is the symbol for, what is the circuit diagram for a simple AND gate? This is a circuit diagram for a simple AND gate, like A, B and Y is the output. Now I want to declare the port under my entity. So I will start with port, PORT port, open bracket. My one terminal is A is called input here, input, semicolon. I want to define this A as input, that's why I have to use in use space standard std logic. This is declaration of one variable of input, semicolon. You can write on continue also, otherwise you can write on another line. Now I want to define my another terminal B colon. B also my input, this also my input basically. Just I am writing a data type called in is a data type basically. Again standard std logic, semicolon. Now I have defined this inputs clearly. Now I have to define my outputs also. That's why I have to take another line Y. This Y is my output, that's why I have to take out. Out is my data type, out standard logic std logic. No, the whole thing inputs and outputs are clearly I have defined. Once you done, close this, terminate this port, semicolon. Okay, so after writing semicolon, now end this entity. How to end this entity? End this entity simply using end name of the entity. What is the name of the entity we have defined? And underscore gate. And underscore gate. And underscore gate, semicolon. Okay, so this is my port declaration for my simple AND gate. So after declaring port declaration for the AND, the next, just already I have shown you, next we have to describe what is the architecture for my basic AND gate. To define architecture, so after declaration of an entity, now define the architecture. For that, what you have to do, give the name for architecture again, give a separate name. So just I am starting architecture block, architecture. I am giving some unique name to my architecture. Like just I am taking some name for my architecture is and underscore logic or something I am writing. You can write anything here, not a problem. Architecture and logic, and underscore logic, anything you can do here. Architecture of and underscore logic of the entity. What is the entity? Entity is and underscore gate. Entity is and underscore gate is. This is the initial description for the architecture. Every architecture start with a keyword called begin. Within the begin, now we have to define the what syntax we want to define. As we know very well, Verilog or a VHDL support some gate primitives. Means these gate primitives are nothing but inbuilt functions. Functions for AND is defined by A and D. Inbuilt function for OR is defined by OR. Inbuilt function for NOT gate is inverter is NOT. Inbuilt function for like this, we have some basic inbuilt available as the libraries. So begin. So my output Y less than equal. This is called non-blocking statement. It's simple. This is similar to equal. That's all. Less than equal. My input variable A. I want to perform what operation? AND operation. You can write down a AND logic like this. In between A and B. Semicolon. No, I want to end this architecture. What is the name of my architecture? And underscore logic. So I have to use end architecture, name of my architecture, and underscore logic. You can add anything here, not a problem. So this is for a simple AND gate. This template will be continued for all different types of codings. What I have did here, support hardly did into just library declaration, in declaration. This is So the same program I want to change for OR gate. So what thing are supposed to be changed? The same thing, just I want to